Hi there. So looking at this equation, it's a rate law equation, and I've got some nitrogen dioxide reacting with carbon monoxide. They have some experimental data for us because the only way we can determine a rate law is through experimentation of some type. So you can see they have four different experiments that they've tried. And in these experiments, what they'll do is hold one concentration constant and vary the other one to see how it changes the rate. What we have to do first, or from this information, is we have to find what's known as the order of reactions for each of the reactants. And again, these can only be found experimentally. So if we're working with this, we say rate is equal to K, and then we're going times the nitrogen dioxide, and we're looking for what X is, and then carbon monoxide, and I like to say what Y is. X and Y there is known as the order of reactions. So in order to find what X or Y is, we want to try and isolate one of the reactants and hold them constant as we look at how the reaction rate changes while it varies with the other concentration. So I see two of them that are held constant for carbon monoxide. I see these two here. Sorry, and then these two here. I can choose either one to work with that I want to. I'm going to choose the top one just because it's on top. So the way I tell my students to set up their equations for this to find out what that is I always tell them to put the biggest one on the top. So I'm going to be looking at the concentrations here of the nitrogen dioxide. And then I want to choose the biggest one and put it on top. So I'm going to put experiment number 2 on the top and then experiment 1 on the bottom. That way I don't have any fractions to deal with. So it's going to look like this. I'm going to say, hey, the rate of reaction 2 over the rate of reaction 1, and that's going to be equal to, and I'm going to ignore K here at this point, and I'm going to ignore the other carbon monoxide because it's constant, it's 1, right? So I'm just going to take a look at the two concentrations of my nitrogen dioxide. So I'm going to look at the concentration of the nitrogen dioxide for experiment 2 and the concentration for experiment 1. Okay, so this is a generic formula. I teach this to my students to constantly use this generic formula to determine what the order of reactions are. And what we're looking for is X right here, right? So whatever makes that true. So just plug in your numbers. So I'm going to put in my 1.43 and my 0.357. And I'm getting those two numbers from the initial rates. And then I'm going to put in the concentrations over here. So I'm putting 1.51 on the top and 0.756 on the bottom. And again, I'm looking to see what's going to make that a true statement. So now all I'm going to do is I'm just going to reduce these things down a little bit. And a lot of times the author of these equations will try to make them some even value that you can work with. And I notice that's true in this one. So 1.51 over 0.756, that's 2, right? So basically they have doubled the concentration of the nitrogen dioxide. And over here, if I solve this fraction, 1.43 and 0.357, I can see that that is a 4. So you can run those through your calculator if you want. And then to solve this, then 2 times 2 to the what is equal to 4. And I think we got that X is equal to 2. So now we know the order of reaction for the nitrogen dioxide. So we can substitute that in here. And this is to the second order. Okay. We're going to do the same thing again for the carbon monoxide. So I'm going to try to take a look for two reactions where the nitrogen dioxide has been kept constant. The author here made them a little bit tricky. They put one in reaction 2 and another one in reaction 4. So I could use those two. And I am going to use these two reaction rates. So I'm going to use those values for my carbon monoxide. So I'm going to be using reaction number 4 or experiment number 4. Let me write that so we're not confused here. So I'm going to use experiment number 4. And I'm going to put it over top of experiment number 2. And again, the reason for choosing what's on top and what's on the bottom is I don't want fractions. So I'm choosing my biggest values to put on the top. So for my rates, again, using that same formula as above there, for my rates, I can see that it's 1.43 for both of these. And for my concentrations, I can see this is 0.532 over 0.266. And we're looking for Y. Now, as I see that there, excuse me, I heard a dog outside. As I see that there, I'm going to take and solve this then. And I notice that this right here is going to be equal to 1, right? Anything to the 0th power is going to be equal to 1. In this case, this is double, so this is 2. And I'm looking for Y. So 2 to the Y, that's equal to 1. So Y here has to be equal to 0. Sorry, that was a 0. So now we know the other piece of information here, and that is our carbon monoxide is to what we call the 0th order. When it's to the 0th order, we don't need we don't even need that in there because that's just equal to 1, right? So we can just get rid of that altogether like that. Okay, last step of this is just finding what K is. You can do that by choosing any reaction and of the 4 that you want there and just substituting in the values into your rate expression and solving for K. So that's what I'm going to do. I'm going to choose experiment number 1. Why? I don't know. Again, you can choose any that you want. I tell my kids at school that you should look around, try to find one that is the easiest looking for you to do. And the experiment number 1 looks as easy as any of them. So I'm going to put in the rate over here. The rate for experiment number 1 is 0.357. And I'm going to start putting in my units for this here. So this is going to be molarities per second or reciprocal seconds or to the -1st, however you want to say that. And on the other side is going to be the concentration of my NO2. So this is 0.756. And this is molarity, and it's squared. Oop, forgot my K in there. So there's my formula, and I just plugged in the numbers. Now I'm going to solve for K. So K then is going to be equal to the 0.357. And this is molarities to the -1st, seconds to the -1st. And underneath is going to be 0.756. And this is molarities, and we're squaring all of that, right? When I crunched this out on my calculator here, I got the answer of 0.625. And then if I'm checking out my units here, I've got molarities on the top and I've got molarity squared on the bottom. So that's going to cancel out the 1 molarity up here, and it's going to leave me with 1 molarity up here on this one, but it's in the denominator, so that means it's going to be to the minus first. So my units then comes out to be molarity to the minus first, and then I still have that seconds to the minus first there. So there's my answer. I hope it helps.